Hello everyone, my name is Radha Pandey and today I am going to present on the topic Zwitter Ion, Isoelectric Point and Electrophoresis. Zwitter Ion. A Zwitter ion is a molecule that has both positive and negative regions of charge. In the solid state, amino acids exist as a dipolar ion called Zwitter ion. The term Zwitter ion is originally derived from the German word Zwitter, which can be roughly translated as hybrid or hermaphrodite. A Zwitter ion is an ion that contains two functional groups. In simple terms, it is an ion possessing both positive and negative electrical charges. Therefore, Zwitter ions are mostly electrically neutral. That is, the net formal charge is zero. Key characteristics of Zwitter ion. They can be formed from compounds like ampholites. Ampholites are those compounds which contain both acid and base groups in their molecule. In this type of ion, the charged atoms are usually held together by one or more covalent bonds. Zwitter ionic compounds have stable, separated unit electrical charges on atoms. These compounds contain quaternary ammonium cations. The structure of Zwitter ion and amino acids. Amino acids are the most common example of Zwitter ion. They are made up of an ammonia or amino group which contains a positive charge as well as a carboxylic group which contains a negative charge. Alpha amino acids are best example to understand the Zwitter ion. When we dissolve an alpha amino acid in aqueous solution, it gives Zwitter ion. For example, if we dissolve RCH NH2COOH in an aqueous solution, then the oxygen atom pulls electrons from hydrogen in the carboxylic function group. Thus, oxygen gets negative charge and formation of H plus ion takes place. Now, this H plus ion gains a lone pair of nitrogen and gets bonded with it. Thus, nitrogen gains a positive charge with formation of NH3 plus and the structure is given here. Here in this structure, we can clearly see that the oxygen takes the electron of hydrogen and now the H plus ion is released in the aqueous solution. Now the lone pair of nitrogen attracts the H plus ion and NH3 plus is formed. So clearly in the Zwitter ion form, we can see O negative and NH3 positive. Effect of pH on Zwitter ion. pH of the solution affects the Zwitter ion. If a solution of amino acid is prepared by using a low pH medium, then the amino group of amino acid accepts a proton and forms a positively charged ion. It happens due to the presence of H plus ions in acidic medium. During electrolysis, this cation goes towards the negatively charged electrode. If a solution of amino acids is prepared by using a high pH medium, then deprotonation takes place in amino acid and a carboxylic group of amino acid denotes a proton and forms the negatively charged ion and H2O molecule. It happens due to the presence of OH negative ions in the basic medium. During electrolysis, this anion goes towards the positively charged electrode. Depending upon the level of pH of the solution, amino acids can be found as anion, cation, or Zwitter ion in its aqueous solution. Isoelectric point. Now here comes the topic isoelectric point, which is the main property of a Zwitter ion. Zwitter ion is that it has isoelectric point which can be represented by Pi, PHI or IEP. This point is the pH value at which the charge in molecules of Zwitter ion is neutral. Usually, The net charge on a molecule is greatly affected by the pH of its surrounding environment. In an acidic medium, it can become more positively charged by accepting protons, while in the basic medium, it can become more negatively charged by donating protons. If we look at amino acid, the amino group is a very effective proton acceptor, and the carboxylic group, on the other hand, is an effective proton donator. In addition, the solubility of a molecule at a given pH is also affected by its pI value, that is, isoelectric point. Here comes the calculation of pH value of isoelectric point. The pH value at the isoelectric point can be calculated from the equilibrium constants of the acid and bases of the Zwitter ion. It is represented by the formula Pi is equals to pKa1 plus pKa2 divided by 2, where Pi represents the isoelectric point, Ka1 represents the equilibrium constant of the acid, and Ka2 represents the equilibrium constant of the base. Applications of Zwitter ions. Zwitter ions are widely applied in the process of separating protein molecules via SGS phase, sodium dodecyl sulfate polyacrylamide gel electrophoresis method, which is one of the most popular techniques used in molecular biology. They also have great potential to be applied in a wide range of medical and biological related fields. Some popular uses include medical implants, drug delivery, blood contacted sensors, separation membrane, as well as anti-fouling coatings of biomedical implants that help prevent the buildup of microbial adhesion and biofilm formation. In the marine industries, Zwitter ionic polymers are used to prevent subaquatic organisms from building up on boards and piles. Electrophoresis. Now, the third topic is electrophoresis. Electrophoresis is the process of separating the macromolecules present in a gel or fluid based on their binding affinity, size, and charge under an electric field. It was President Frederick Ruiz who observed electrophoresis for the first time in 1807. The process has several uses in the analysis and separation of biomolecules like plasmids, protons, nucleic acid, DNA, and RNA. Anaphoresis and cataphoresis. The primary classification of electrophoresis includes procedures like anaphoresis and cataphoresis. Anaphoresis is an electrophoresis of negatively charged elements called anions, while on the other hand, cataphoresis is the electrophoresis of cations or positively charged particles. Working principle of electrophoresis. The working principle includes charged molecules placed in an electric field move in the direction of the positive or negative pole. The movement ultimately depends on the charge of the macromolecule. Proteins, if negatively charged, will move towards the anode and the cathode if they have a positive charge. Because smaller molecules migrate faster than the larger ones, scientists can easily measure the travel distance and make use of logarithms for determining the size of the particle. Here in this picture, we can clearly see that the neutral amino acid is in the center, while if we have applied the electric field, the acidic amino acid will move towards the anode, that is the positive electrode, while the basic amino acid will move toward the cathode, that is the negative electrode. Types of electrophoresis. There are mainly two types of electrophoresis. Name: capillary electrophoresis and slab electrophoresis. Capillary electrophoresis. Using this separation method, you can separate the charged particles with the help of their various migration rates in the electric field. It completely depends on the size of the particle as well as the charge on the particle. Capillary, capillary electrophoresis is of two types: gel electrophoresis and paper electrophoresis. Slab electrophoresis. The next type of the electrophoresis is slab electrophoresis. It is popular method for separating proteins. We can use this method to analyze many samples at the time using one-dimensional format. This method does not use any specific instrument like in capillary electrophoresis. We use so many instruments, but in slab one, we don't need to use specific instrument. Slab electrophoresis is further divided into three types: zone electrophoresis, immunoelectrophoresis, and isoelectrophoresis. Thank you. Here's my topic end.